In this video, we're going to graph a total revenue curve for a perfectly competitive firm and then for a monopoly. So for perfect competition, a firm's total revenue is given by price times quantity, price per unit of output times the quantity of output sold. So just abbreviating, TR equals P times Q, where P is price and Q is quantity. And in perfect competition, the price is the equilibrium price. The competitive firm is a price taker, so it takes price as a given. It doesn't set it. And the equilibrium price occurs where the market quantity demanded equals the market quantity supplied. So in example 1, the market price in this competitive market is $10. We want to solve and graph the competitive firm's total revenue curve or function. Total revenue is price times quantity. Given that the market price or equilibrium price is $10, total revenue equals 10 times Q. Notice that the slope of this total revenue function is 10. Every time this firm sells one more unit of output, total revenue goes up by 10. And that's basically our definition of marginal revenue, the change in total revenue from producing and selling one more unit of output. So the graph of 10Q is over here on the right. It's just a ray from the origin with a slope of 10. I have a couple points here. So if Q is 2, total revenue is 20. 10 times 2 is 20. If Q is 12, total revenue is 120. So just 10 times Q, which is 12. Give us total revenue of 120. So the perfectly competitive firm will always have a straight line total revenue function that looks something like this. All right, let's move on to example 2. In example 2, we've got a monopoly. The monopoly faces an inverse demand of price equals 20 minus 2Q. We want to solve and graph the firm's total revenue function. So once again, total revenue is price times quantity. Here things are a little bit more complicated. Price is going to be given by 20 minus 2Q. So I'm going to substitute 20 minus 2Q in for P, and then I'm going to simplify this. So multiplying through by Q, total revenue equals 20 times Q minus 2Q squared. One thing to note, if Q is 0, if we plug 0 into this equation, total revenue would be 0. So that's going to be 1 point on the total revenue curve. Another thing to note, if P equals 0, and I'm just going to go back to this inverse demand. Notice that if P equals 0 and we solve for Q, you get 0 equals 20 minus 2Q, or 20 equals 2Q, Q equals 10. So that's an interesting point here, that when output is 10, price is 0, so once again total revenue would be 0. So if P is 0, Q is 10, and total revenue is 0. So we got another point on the graph where total revenue is 0. Total revenue is going to be maximized at the midpoint of the demand curve. So when graphing total revenue for a monopoly, it's usually useful to try to find where total revenue is going to be the highest, and that is going to occur at the midpoint of the demand curve. So looking at this price equals 20 minus 2Q, the midpoint of this inverse demand occurs at price equals $10. Just as half this value of 20 is 10. So half the value of the vertical intercept. And at P equals 10, just plugging in 10 for P, we'll solve for Q, and we'll learn that at the midpoint of the demand, price is 10 and quantity is 5. Again, the meaning of this point is that is where the firm will earn maximum total revenue at Q equals 5 and price equals 10. And we can be more explicit. 10 times 5 is total revenue. In this case would be $50. So $50 is a maximum total revenue for this firm. Okay, moving on. So here's our total revenue function. And if we're to graph that using the information we found in the last slide, we said when Q is 0, total revenue is 0. So that's 1 point on total revenue. We also said that when Q is 10, all right, or P is 0, Q is 10, total revenue once again is 0, and then we found the maximum point where total revenue is going to be 50 at 5 units of output. So that's how I like to graph total revenue. Basically get these 3 points, these two endpoints, and then where total revenue is maximized.